Hi, I'm glad you could make it back to the continuation of the SolidCAM Milturn training videos. In the previous video, we went in and we put the face pocket on the front of the part, and that was dealing with the straight walls. And we knew from looking at the model there was drafted surfaces on those walls. And if I were to go back to the original SolidWorks model itself, and if we were to look at the feature that actually created that, I can see that that is a 10-degree drafted feature on that wall. So I'm going to kind of come back over to the SolidCAM side of things, and let's go ahead and let's deal with the 5-axis motion to deal with that cut. So to do this, we were working in the 2D tab before, so now we're going to go over to the multi-axis tab. Now keep in mind with this type of operation, there are more than one way of doing this. So this is just one example of one way that you would do this. I'm going to go into simultaneous 5-axis milling, and I'm going to come in and select which mode of operation that I want to do based on the geometry that I have. So in this case, I want to do parallel to curve. And so we're going to pick surfaces and pick a curve that the toolpath will be parallel to. So the first step is from Mach 1 position 1, which is the primary rotational axis on a 5-axis machine. I'm going to come in and select the drive surfaces that I want to machine. Now, everything that we've been doing up to this point, we've been picking edges and circles and things like that. Now I'm going to come out and actually be picking the surfaces of the part that I want to machine and drive the tool around. So I'm just going to come in and capture the surfaces for this example. I'm going to pick all the wall faces. And then because we're parallel to a curve, I need to define an edge curve. So I'm going to come in, select new, and then chain the bottom curve of this part. Now, depending on the way methodology, you might be chain the top. Sometimes you might chain the bottom. It just really depends on what it is that you're trying to accomplish. So on the area, the type here, I'm going to determine this by the number of cuts, and I want this to do it in one pass. So we selected our faces, we selected our curve, we kind of gave it some instructions on how we want to deal with it. Now we're going to come in and pick the tool. I'm going to use that same 5mm tool that we used to cut the primary pocket to do the swarf cutting on the side. Now, in the tool axis parameters tab, really not too much here to change. Let's go in and look at the tool axis control. So the output type, I do want to be moving all 5 axes. Depending on the type of geometry, this could have different options here. You could have, I want to limit it to only 4 axis. In this case, I do need 5 axis of simultaneous motion. I need the C axis to be rotating and the B axis to be moving as well. I'm going to be tilted relative to the cutting direction, which means that if I left it like this, my tool would be perpendicular to that face. So what I need to do is instigate a side tilt angle. So in this case, I want to use the side of the tool. So I'm going to tell it that I want a 90-degree side tilt on the face itself. Now let's go ahead and hit save and calculate on this, and let's see what we get. It will come out and it will give me a swarfing operation. But you'll notice here we're plunging right on the wall. I probably want to incorporate a lead in and a lead out with this toolpath as well. So I'll go to my link tab. And so my first entry and my last exit into the part, because we're only coming in once and leaving the part once, this is where I'm going to change it. Right now I'm set to do not use lead in or lead out. I'm going to use a lead in and a lead out, and then I'm going to tell it how I want to engage in and enter the material, enter and exit the material. So I'm going to change this from automatic arc, and you have a lot of different methodologies depending on the part that you're working with. I'm just going to use a tangent arc move, and then I'll give it some parameters for the size and the distances. So I might give it a arc sweep of, let's say, 60 degrees with a diameter that is relative to the tool, so 80% of the tool diameter, in a fixed orientation with a tangent arc move. I think that should work out rather well. Same thing with the lead out. I want to use a lead in and lead out. Once I have that, it'll activate this button. And then here I can change this to be tangential arc move in, and then change the necessary parameters for the size constraints of what we're dealing with. Once I have my parameter value set, let's go ahead and recalculate this and see what we have. So I like what it's doing. It's leading in and leading out nicely into the part, but I don't like where it's starting. So what I'm going to do is go back up to my tool axis parameters in sorting. And so when I go to sorting, I can initiate my own start point. So by selecting this, it'll activate this window. And I can say, well, use my own start points. And then I'll click this button over here and I'll pick on the profile where I want this thing to lead in and lead out. And I'm just going to kind of sketch that location right there. And what we should see is it should move the entry and exit from this location to perhaps a more suitable location that to our liking. Once we have that set, we'll recalculate this toolpath. and it will move the start point out accordingly. If I were to take this into solid verification, solid verify, there's our part in our current state. We'll go ahead and we'll let that play. We can see that the B-axis is now moving. So we've activated a full 5-axis swarf cutting style toolpath. As it moves around those corners, enters and exits the part. I can run a quick compare. It's always a good idea to make sure what you did is correct, and we're pretty safe there. Now, again, I will kind of exit out, take the entire operations into my machine tool simulation. So by doing that, it will read all of these operations, especially when I come down and say this operation right here, it will update the current to the current state. And if we were to look at this from the front of the machine, let's say, let's fit that over here and we'll kind of move him over this way just a little bit. And we'll let that play. So what we should see here is we're going to be both activating the C-axis as well as the B-axis, depending on the part. Didn't really have to move the B-axis that much here at all for that particular example. But thank you for watching this video. And on the next videos, we're going to deal with some of the OD operations, some OD drilling and pocketing, and then we're going to transfer the part to the subspindle, do some backup part machining operations in the upcoming videos. Look forward to seeing you there. Have a great day.